So these are the 5 tricky questions from the NEET 2022 physics paper. So I mean, of course, the students who had practiced a lot of questions on doorstep tutor would have just sailed through this exam because the questions were as we had expected. So nothing too tricky about those, but especially these questions, some of the students might have faced some problems. So let's just discuss those. So here the first question that we have taken is actually here. You have been asked about the Snell's law. So as we had said in the class yesterday before the exam, we have told you that Snell's law was important, and indeed there were questions on Snell's law as always. So here the only tricky thing is that here we have been told that the angle between the refracted and reflected ray. So there are two rays. So this is the incident ray. It gets divided into two parts. One of them is reflected and the other is refracted, and this is what typically happens when you look at glass. Not everything is just transmitted through. A part of the rays coming from the object are actually reflected back to our eye. So this is what actually happens, and here we have been told that this angle, the reflected and the refracted ray, this angle is actually equal to 90. This is what we have been told. Okay, and we have also been told that the refractive index of this is, of course, this is air, and the refractive index of this medium is actually √3. And now we have to find out the angle of incidence. So see, the first the law of reflection tells us that this is the angle of incidence, angle I. Then of course this has to be the reflected angle, and this also has to be angle I only. Now we also know that this surface is actually 90 degrees. Okay, so I'll just change the color a little bit and I'll tell you that this is actually 90 degrees. So which means that if this angle is I, this angle is equal to 90 degree minus I. Okay, this has to be the case. Okay, one is I, the other has to be 90 minus I, because that entire thing, the sum of two, is actually equal to 90. Now at this point we also know we have been told from the question that this angle is 90. Which means that if this is 90 minus I, this angle should be equal to I. Now this means that the angle of refraction, okay, angle of refraction, this angle will be equal to 90 minus I. Okay, so very simple. We can just derive the relationship between the angle of incidence and the angle of refraction. Now from here on things become very simple, because we know that the refractive index √3. If you had drawn this diagram, the problem is actually solved. Okay, so this is equal to sine of I divided by sine of R, and of course this is nothing but sine of angle of incidence divided by sine of 90 minus I. Okay, from here, okay, because we know that this angle of refraction is nothing but 90 minus I. This is equal to sine I divided by cos I. So here we have to study a little bit of trigonometry, which we have covered in our class on basic mathematics for the NEET, for the medical students, okay, who have not really taken maths as their subject. So they need to know this basic mathematics, and this is equal to tan of angle of incidence, and this is nothing but √3, and we know the angle for which the value of tan is actually √3, and that is nothing but pi by 3 or 60 degrees. Okay, so very simple. Okay, not difficult. Now let's move on to the next question. Here we have been told that again this question is not very tricky. We have to just keep if you had practiced a lot of questions from doorstep tutor, you would have encountered several such problems. It should not be a surprise to you, but again some of the students might become confused. Okay, so we are talking about the fringe width. Okay, so let's just talk about the fringe width in this question. So fringe width, we know that it is directly proportional to lambda. Okay, that is all we need to know. We don't really need to understand the full formula for what the fringe width formula would be, but we should only understand that it is proportional to the lambda. So now if the lambda or the wavelength is actually decreased from 600 to 400, okay, the fringe width would actually decrease by a factor of 400 divided by 600, which means that this will be equal to 2 by 3. So this is fringe width. So number of fringes would increase by the inverse of this factor. So they would actually increase by 3 by 2. So number of fringes was 12 in the beginning. So the new number would be 3 by 2 into 12, which is equal to 18. Okay, very simple, not anything difficult. If you had studied your NCERTs and then you had practiced a few problems. Now this is a little bit of a tricky question. See, here they have been told that the T1 and T2 is the energy of the electron first and second excited states. Okay, so it is energy of the electron not in the ground state. For hydrogen atom, the ground state is n equal to 1 when the principal quantum number is equal to 1. But here we have been told that this is the first excited state, which means the principal quantum number now became 2. And then subsequently, so here in T1, the principal quantum number is 2. For T2, the principal quantum number is actually equal to 3. We know that the energy of an electron only depends upon the principal quantum number. N is directly proportional to 1 by n square, which means that it varies as the square of n. As the n increases, the En decreases, energy decreases, but as a square of n. Okay, so this essentially means that for T1 is to T2, I typically like to write it like this. I clearly specify in terms of mathematics T1 and T2, we have been asked their ratio, and now this is of course n1 square, and this is equal to n2 square, which means that the excited state 1, but this is nothing but 1 by 2 square is to 1 by 3 square. Okay, so this is the ratio of T1 and T2. Okay, so this is the ratio of T1 and T2, and if you want to write this is typically what this has been asked in your problem. We have been given as a fraction, so we convert this to fraction, so this becomes 9 by 4 or 9:4. Okay, again very simple, but don't get confused. The only confusing thing in the last question was that we have been asked about the first and the second excited state. The ground state has been intentionally left out. Okay, we are not talking even about the ground state, we are not talking about n is equal to 1. Okay, so that is the thing. Now the next question is that again we have been given, it's a slightly indirect question, little bit of trigonometry has been used. So again trigonometry becomes very important in this question as well. See, the displacement time graph of two moving particles. So there are two moving particles, whether it's one or two, it does not really matter. The main thing is that this is the displacement time graph, and the slope of the curve in one case is 30, in the other case is 45. So we have been asked to find the ratio of two velocities, which means that we have been asked to find the ratio of 30 degrees to 45 degree. That's what we have been asked. Now we know that the equation for the motion, from the equation of the motion is that this is equal to ut plus the intercept or the initial thing is actually 0. At time equal to 0, s is equal to 0. So this is our equation. Now in this equation we know that the u appears, or the velocity actually appears as the slope of the curve. Of course this is very understood also, because the velocity is the slope of the displacement time curve. We know that. Okay, so which means that this our velocity u is actually proportional to tan of 30 degrees. Okay, very simple. I'm not writing something complicated here. This is what it would be, because it is proportional to the slope. Now this of course means that our tan of 30 degrees is to the ratio that we required, the velocity would be in the first case to second case would be tan 30 is to tan 45. That is what if the angle is 30, angle is 45, and our velocity is equal to tan is proportional to the tan of the corresponding angle. So our ratio would become tan of 30 degrees is to tan of 45 degrees. Nothing very difficult, very simple. Okay, now we know that tan 30 is actually equal to 1 by root 3. So again very important basic trigonometric ratios, those have to be covered. If you haven't covered those, then you might end up in trouble. Our answer is 1 by root 3. So very simple. Now the next question and the last question for today is of course very direct question, but the problem here is that people don't take this particular section very seriously. This is coming from the Heisenberg's uncertainty principle, and this is important. Okay, so what we are saying is the de Broglie wavelength and the associated momentum. What is the relationship between two? How does the de Broglie wavelength and the momentum, how are they related? So they are related by lambda p, where p is the momentum, lambda is the de Broglie wavelength. So typically we write it lambda d, just to denote that this is de Broglie wavelength. It has some special meaning. Okay, and this is actually equal to h. So here the graph of this curve, what does it mean? It means that as my momentum is increasing, okay, so if we write it as we can either write it as p is equal to h by lambda d, or we can write it as lambda d is equal to h by p, which essentially means that as p increases, our lambda actually decreases. This is what this is saying. As I increase p, as I increase the value of p, then the lambda d value actually decreases. So this is what it is saying. And of course, the graph has to be in this shape. It has to be in the shape of a hyperbola. It cannot be a linear line, okay, because this is inverse relationship exists here. Okay, so now we know that the correct answer would be this again. So very simple. Okay, if you had remembered this formula directly from the NCERTs, nothing there, just you have practiced this question and you are done. No need for doing anything else, just practice the questions, that is it. Okay, so hopefully this class was useful. If you find any other interesting problems in this year's NEET, do put them below. I'll be very happy to answer those questions, bring you another class with those interesting problems. Thank you very much.